Can you look at someone else's work and use the same procedure on a new question that you're working on? Let's see what that looks like. So here's the solution somebody else came up with for isolating y starting from this linear equation. We have everything equals 0. The x, the y, and the constant equals 0. The x, the y, and the constant is 0. Circle the 2y and subtract the 3x both sides. 2y minus 18 is equal to negative 3x, which is that step. And now what happened? Looks like 6y appears by itself by adding 12 both sides. We'll do the same thing over here. Add 18 both sides. 2y is equal to negative 3x plus 18. And now what happened? We went from 6y to y. That's a divide by 6, isn't it? What you do to one side, you do the other. So that's what we'll do over here. Divide by 2, divide by 2. Y is equal to negative 3 halves x plus 9 is what it is. Good. The equation's starting to look a little bit different here. Take a look. Now we have some brackets. We still want to solve for y. That's your job. Here's where you'll see different methods to solve for y. And I encourage you to try different methods out. The first one, it looks like the y was isolated by subtracting 3 both sides. Well, let's isolate this y by subtracting 4 both sides. That becomes a 0. We have y is equal to 3 bracket x minus 2 subtract 4. And that's the step we're on. Now it looks like the brackets disappeared. How? That was a distribute. And we'll do that over here. That's a distribute. Y is equal to 3x minus 6 minus 4. So we're at this step. Now we can collect our like terms. We have y is equal to 3x minus 10. And that happened over there too. So there it is. Y is all by itself here. Now let's look at this question and see if you can come up with a different method. Now in order to get y by itself, you could subtract 4 both sides. That's fine. We did that. But what if you went and did this first? Totally allowed. 3x minus 6. And now subtract 4 both sides. Y is equal to 3x minus 10, which gives the same result. Now what happened here? Isolate the y. Add 5 both sides. Fair enough. Isolate the y. This time we'll add 4 both sides. And now from here to here, the brackets disappeared. Let's do that over here. 3x minus 9 plus 4. And now to get to the last step, we collect like terms. Like this one, negative 8 plus 5 made a negative 3. So then a negative 9 plus 4 is going to be a negative 5. And there it is. Y is all by itself here. From this original equation, we changed the looks of the linear equation. Are you convinced that those two equations mean the same thing? Well, pull out Desmos and take a look. Here is Desmos. The original question read y minus 4 equals 3 times x minus 3, and it looks like that. And then you simplified to the second one. Let me darken it. Wow, there it is. Red turns to blue. Same equation. Okay, what happened here? Oh, there's a negative in front of a bracket. You should be thinking -1 right there, -1. Okay, we need y by itself, so subtract 4 both sides. That seems reasonable. Y by itself, subtract 2 both sides. Y is equal to -1, x minus 5, subtract 2. So we are at this step. Next one, all of a sudden the brackets disappeared. How? Well, there was a distribute. Remember, negative times negative makes a positive. Let's do that over here. Y is equal to -x plus 5, subtract 2. Same step. And now from here to here, it was just collect like terms to get -2. And then we'll do the same thing over here. -x plus 3. And let's check if those two are the same. Here's the equation we started with. And here's the equation we ended with. Are they the same? There's 1. And there's 2. They are. Here's a fraction one. Now look at the beginning equation. We have a fraction in front of the bracket. Same thing here, fraction in front of the bracket. And let's see what happened. It looks like we went, here's x minus 8, x minus 8. Somehow this fraction became a 1 or just disappeared. And then somehow this became a 2 and this became a 6. What happened? I multiplied the left side by 2 and the right side by 2, because if I do that, 1/2 times 2 makes that 1. And 2 times y minus 3 makes 2y minus 6. And there was a step right here you could have shown. And the 1/2, I mean, you could have put the 2 in front like this, x minus 8. And then you could see that those two make a 1. And you could see the distribute here. Well, let's do that over here. You see this 5? It's a fraction. We don't like fractions. If we decide to clear the fraction, we could times the left side by 5 and the right side by 5. And if you multiply the right side by 5, this whole thing is multiplied. That means 5 divided by 5 is 1. And here we can distribute the 5 through. 5y minus 5 equals, keep the 3 and the x plus 2. Now, here's the step. From here to here, what happened? Add 6, both sides. And that made a 0 pair. That was just shown. Let's do the same thing. We're going to add 5 both sides. That makes a 0 pair, and we can write this as 3x plus 6. We didn't need to keep the brackets here because there was a 1 in front, you see? But we had to keep it here because there was a 3 in front, and then distribute. And have the plus 5. So we're at this step. Now, can we collect any like terms? Yes. 5y is equal to 3x plus 11. We're at this step. And now divide by 5. Y is equal to 3/5 x plus 11 over 5. I really want to encourage you to practice plugging in equations into Desmos, especially when it comes to fractions, because there is a little bit of a learning curve there, making sure that you're getting the exact equation in. The first one I have in looks like that, and then let's see if it's the same. It is. Good. Are we able to use a different method to get to this spot? What would happen if we distributed the fraction through first? would we get to that same final result? Y minus 1 equals 3/5 x plus 6/5. Because 3 times 2 is 6/5. We want to add 1 both sides. Y is equal to 3/5 x plus 6/5 plus, and let's make this 5/5, 3/5 x, and then adding these two fractions makes 11/5. Same answer.